Lesson 6.4 is about rational exponents. If you remember, a rational number is a number that can be written as a fraction. So what we're dealing with here is exponents that are not whole numbers anymore, but they are fractions. And we're going to learn how to simplify expressions that have fractional exponents. Radical expressions can be written in exponent notation in this way. So if you have the nth root of some number, x, it can be written as x to the 1 over n power. For example, the square root of 5 can be written as 5 to the 1/2 power. Or the square root of 4 can be written as 4 to the 1/2 power. That's what we're dealing with in this lesson. So the square root of 36 is equal to, that's a typo there, square root of 36 is equal to 36 to the 1/2 power. Since the square root of 36 is 6, 36 to the 1/2 power is also 6. The cube root of 64 is equal to 64 to the 1/3 power. Since the cube root of 64 is 4, 64 to the 1/3 power is also 4. This is supposed to be an exponent. The fourth root of 16 is the same thing as 16 to the 1/4 power. Since the fourth root of 16 is 2, 16 to the 1/4 power is also 2. So we can simplify each of these expressions by using this exponent information. So 216 to the 1/3 power is the same thing as the cube root of 216. If we're going to take the cube root of 216, it would be helpful if we factored it. So 216 is 6 times 36. 36 is 6 times 6. So as it turns out, 216 is a perfect cube. We have 3 6's. So the cube root of 216 is 6, which means 216 to the 1/3 power is also 6. In example B, we have two different ways that we can do this. We can say the square root, or 7 to the 1/2 power is the same thing as square root of 7. So this is square root of 7 times square root of 7, which would be square root of 49, which equals 7. The other thing that we can do is we can recognize that just like if you have x squared times x to the 3rd, you would add exponents, and that would give you x to the 5th. We could do the same thing here. Since we have matching bases here of 7, we can add 1/2 plus 1/2. That would give us 7 to the 1st power, which is the same thing as 7. So we can either multiply our bases, as we did here, or we can add our exponents, as we did here, when they both match. If only one of them matches, as in example C, you have to work with the part that is non-matching. Since these are both 4th roots, I can multiply the 5 times 125, and that gives me 625. So this is 625 to the 1/4 power. The 1/4 power is the same thing as the 4th root. So if we factor 625, we know it's 5 times 125. 125 is 5 times 25. 25 is 5 times 5. So 625 is actually a perfect 4. And so the 4th root of 625 is 5. 64 to the 1/2 power is the equivalent to the square root of 64. And we know the square root of 64 is 8. In example B, here we have matching bases again and matching exponents. So we could do square root of 11 times square root of 11, which is the square root of 121, which is 11. Or we could add our exponents because the bases match. 1/2 plus 1/2 is 11 to the 1st power, which is 11. example C, our exponents are matching, so we have to multiply bases. 3 times 12 is 36 to the 1/2 power. A 1/2 power is the same thing as a square root. Square root of 36 is 6. So, if the nth root of a is a real number, and m is an integer, and m divided by n is in lowest terms, then we can say this. A to the 1 over nth power is the same thing as the nth root of a. Or if you have numbers for the numerator and the denominator becomes the index here, and the numerator is the exponent. So, for example, the 4th root of a cubed is the same thing as a to the 3/4 power. So, writing these in radical form, the exponent, or the numerator, becomes the exponent. The denominator is the index. So x to the 3/7 power is the same thing as the 7th root of x cubed. In this example with y, we have a negative 3.5. We need that to be a fraction. So if we change 3.5 into 3.5, then make that improper, 2 times 3 is 6 plus 1 is 7. We have 7/2 here, but it's still negative. What do you do about a negative exponent? A negative exponent means, I better write this down, a negative exponent means make a reciprocal. Can't spell. Okay, so we have y to the negative 7/2. Making a reciprocal gives us 1 over y to the 7/2. And then changing the exponent into a radical, we have 1 over the square root, because the denominator is 2, the index is 2, y to the 7th, because the numerator is a 7. We could rationalize this denominator and work with it further, but we're going to leave it like that for now. In example B, the square root of a to the 5th in exponent form. Our index here is an unwritten 2, so that means it's a to the 5 over 2. Here our index is a 5, and so this is equal to b to the 3/5. The index is the denominator, the exponent is the numerator. One use for rational exponents is Kepler's third law of motion, which shows how you can approximate the period or the time that it takes for a planet to orbit the sun using this formula, period equals d to the 3/2, where d is the distance from the planet to the sun in astronomical units. So how many Earth years does it take Mars to orbit the sun if Mars is 1.52 astronomical units from the sun? So we're trying to find the period to Mars, so that's going to be 1.52 to the 3/2 power. And you would put this into your calculator as 1.52, raise it to the 3/2 has to go in parentheses, so parentheses 3 divided by 2, and that gives you 1.87 years. Okay, this lesson will be continued in part 2.